Hi everyone, this article describes how to do the basic engine setup in a modular ECU. So this assumes that we're either starting with a base map or we're starting from scratch and we're making a base map from nothing. It's from this that the ECU actually works out what it has to do to run the engine, so it's important that we get this right. If we don't get it right, then we're going to spend ages trying to solve problems that are going to be very strange. If it's not right, it'll make your life harder than it needs to be, and that's the opposite of what we're trying to do. Okay, so the first tab we'll look at is the engine tab. So if you select this and then click on details, you'll see the options that we have. The first is engine capacity in cc's, or cubic centimetres, or mils, thousandth of a litre. So if it's a 2 litre engine, you'd enter 2000 here. Now if you don't know what this is, but you know the engine type, you can normally look it up and you can find that a 1J is 2500 cc's. Now this is the actual swept volume of the engine. You don't double it for a 2-stroke or rotary or anything like that. It's just, you know, the swept volume of the engine. Now the next setting is the number of combustion chambers, number of rotors or cylinders. So 6 for a JZ engine, 2 for a 13B, that sort of thing. Pretty self-explanatory. The only thing that I would suggest is that if you're trying to do something funny, like you're pairing methanol injectors on a 2-rotor engine, you want to run you want to run the injectors in pairs, you can tell the ECU that it's a 4-rotor engine, but that 1 and 2 fire together and 3 and 4 fire together, and then it'll fire the correct amount for the injectors. And that way you can run an individual injector output per injector on the engine. That's a pretty rare case though. The next setting is separate banks. So if you enable this, then the ECU considers the engine to be in 2 halves. So you can consider that to be the odd bank and the even bank of the engine, for example. All the fuel calculations, like the transient throttle manifold pressure and the fuel film volume, are calculated individually for each of the 2 banks then. In this case, the 2 banks can each have their own map sensor, and also if you're running pressure ratio, they can have their own exhaust manifold pressure sensor as well. So this is particularly useful on dual plenum engines like the VG30 and V12 engines, because often the pressure in each inlet manifold is not exactly the same. So you can, even with balance pipes, so you can run a separate map sensor on each one using, say, the 2 inbuilt map sensors in the ECU, and you can run each half independently. You can also run the individual boost control on this sort of engine this way. Now you can also select whether the halves are defined as being the first half and the second half, or the odd and the even half. So on most V engines you have an odd bank and an even bank, so that's what you'd select. But with some engines they're named where one bank is the first half numbers, like the Allison V12 for example has got 1 to 6 is one bank and 7 to 12 is the second bank. For that engine you select as being first half, second half, and that way the number outputs on the ECU can actually correspond exactly to the cylinders. You could actually do the same thing on the RB26 GTR engine, because the front half and the rear half have each got their own oxygen sensor, so you can run it as a separate bank engine that way. And similarly with a 13B, you can run a separate exhaust manifold pressure off each rotor and run each rotor independently. Finally, the firing mode can either be 4-stroke or 2-stroke. So a stroke is defined as the distance between top dead center and bottom dead center, which is 180 degrees of crank rotation. So a 4-stroke engine does 4 times 180 degrees, so 720 degrees per power stroke. And a 2-stroke does 2 of those, 360 degrees per power stroke. So a rotary is a 2-stroke engine because it does a power stroke every 360 crank degrees. Both of these have got suck, squeeze, bang, blow cycles happening within that period of time. That's just part of how the Otto and diesel cycles are defined. Now note that this doesn't affect the ignition output firing pattern, we'll talk about that later, but it does affect whether the injectors are fired every 360 or every 720 degrees. So for a 4-stroke piston engine, you'd select 720 degrees, and for a 2-stroke piston engine or a rotary, you'd select 360 degrees. The next section we'll cover is the outputs, which is all the things that the ECU actually controls. Go to the Outputs tab and then select Fuel System from the ribbon. This is where we enter the basics of the fuel system. Now the first is what sort of fuel pressure control we're using. In general there are 2 types. There's manifold referenced, where we have a constant fuel pressure difference between the manifold and the fuel rail. And the other is fixed fuel pressure, where the fuel pressure doesn't change with manifold pressure. So therefore the differential fuel pressure changes. So I'd select manifold referenced if you're going to have a constant differential fuel pressure, and fixed if the gauge pressure is going to be constant and the differential fuel pressure changes with manifold pressure. Often these are called return or returnless style systems, but that's misleading because you can have a returnless that is manifold referenced if you want, and you can have a return system that doesn't have manifold reference if you want to. Generally we prefer to see manifold reference fuel systems where possible, so that the injector performance is consistent, but the ECU can handle both systems no problem. The type that the ECU doesn't support is a rising rate regulator. So in a rising rate regulator, the fuel pressure actually changes at a higher rate than the manifold pressure. So you might see, say, a 10 kPa increase in manifold pressure, and that might mean an increase of 20 kPa to the fuel pressure. If you have a fuel pressure sensor, then the ECU can measure that pressure and then adjust the injectors to suit. The next setting is the nominal fuel pressure. So this should be set to the pressure that the fuel system sees under the maximum power condition. If the fuel pressure sensor fails, the ECU will use this as a fuel pressure value. In a manifold reference pressure system, there's a differential pressure between the rail and the manifold. And in a fixed fuel pressure system, it's the fuel gauge pressure. Typical fuel pressures are 3 bar for manifold referenced and 4 bar for fixed. So that's 300 kPa, 400 kPa, or 43.5 and 58 psi. The next option, fuel modelling, is how the ECU determines what the fuel pressure is when it does its calculations for the injector. So in nominal, the ECU will just look at the fuel pressure setting that you've entered, and in measured it will actually read the pressure from the fuel pressure sensor. In general, we prefer the measured option. The next checkbox is to trim for fuel density. The fuel density changes with temperature, and this change actually is different between petrol and E85. So the ECU has a built-in table to compensate for the change in density, and if you have this checkbox enabled, the ECU will look at the fuel temperature and make changes accordingly. If there's no fuel temperature sensor enabled, then the ECU uses a model for the fuel temperature which starts off at the engine temperature and then stabilises at a steady temperature after that. For measuring fuel temperature, you can either use a discrete fuel temperature sensor like a coolant temperature sensor, or you can use the temperature output from an ethanol content sensor, since they output both the ethanol percentage and the temperature. If you prefer to model heat soak effects yourself, then you can turn this off and then compensate for this in the fuel modelling. If you now click on the injector staging option, you can set up the stage injection modes. If you aren't running stage injection, then the number of injection stages should be set to 1, and that's all you need to do. Otherwise, set the number of stages to the number of injection stages you'll run, for example 2 on a factory RX-7, and then set the off time for each stage. So this is the amount of time that the injector is required to stay off before it can start another pulse. In general, we recommend 2 milliseconds for this. This seems to be a good amount of time for the injector to turn off and then turn on again and deliver a required amount of fuel. Next, in the injection panel, select injector type. For each stage of injectors that you have, you need to select the injector type from the drop-down list. If your injector isn't in the list, then you can select custom and enter the fuel flow rate as a function of fuel pressure, and the dead times as a function of fuel pressure and battery voltage separately. Now that we've fully described the fuel system, we need to talk about the ignition output system. So the first step is to go to output control from the ignition panel. From there, the first thing we need to do is set the ignition output mode. For a rotary, or an engine with 2 spark plugs per cylinder, there are several different modes that we can use. Direct fire rotary / 2 plugs per cylinder is the default mode that you'd use if you're running a single coil per spark plug. In this mode, you must select the firing pattern as well, which will need to be 720 degrees if you're running a piston engine with 2 spark plugs per cylinder, or more commonly 360 degrees if you're running a rotary. If you don't have a cam trigger on a 4-stroke engine, then you'll need to select the ignition to be every 360 degrees. And a cool feature is that if you have a cam sensor, but the ECU triggers off the crank first, then you can select the ignition to fire every 360 degrees until it sees a cam sensor trigger, and then switch over to 720 degrees. That allows engines to start very quickly, but still run direct fire when it's running. The next available mode for rotaries is FD, where we have wasted spark on the leading plugs and direct fire trailing plugs. So this is for the factory FD ignition system. FC is another mode where we have waste spark on the leading plugs. The trailing plugs are direct fire, but it's done with an addressing mode igniter instead of 2 separate ignition outputs, one for each coil. And this is the factory ignition system on the RX-7 FC. For a single plug per cylinder, so most piston engines, the following modes are available. Direct fire, single plug per cylinder. In this mode, the ECU allows a single ignition output per cylinder. The ignition firing pattern must be set to 720 degrees, 360 degrees, or 720 switching over to 360. The ignition output mode must be set to 720, 360, or 360 then switching over to 720 when we get the cam signal. Another mode is wasted spark. In this mode, we only have 1 ignition output for every 2 cylinders, and the firing pattern needs to be set to every 360 degrees. This works automatically for 4-cylinder, 6 cylinders, and 8-cylinder flat plane engines. For an 8-cylinder cross plane, you're going to have to change the ignition firing order so that ignition outputs 1 to 4 correspond to the 4 pairs of cylinders which fire at the same time. Single distributor is another mode. In that mode, only a single ignition output is enabled, and the firing pattern is set automatically based on whether it's a 4-stroke or a 2-stroke engine and the number of cylinders. The final mode is twin distributor, where 2 ignition outputs are enabled, and again the firing output pattern is set automatically by the ECU. The next setting to verify is the ignition sense. This should normally be falling edge brackets normal. Very few systems require a rising edge, and if so, then you should know about it and have seen the scope waveform for yourself. If you set the ignition to rising edge incorrectly, then that can burn out igniters and or coils. The dwell timetable can now be set as a function of battery voltage and engine speed. Lastly, but definitely not least, is the period angle offsets. These are the angles at which each cylinder fires in sequence. So for example, if your firing order is 1342 on a 4-stroke piston engine, then the period offset angles are going to be 0, -180, +180, 360. This offset angle is used for the injection timing as well as for the ignition. You can set this up using the wizard though, so you just enter the firing order and then the software will work out the angles for you. After this, you'll need to set up the triggering modes correctly. Thanks very much.